Okay, so we're at the last tail end of the study guide, but looking at number 18, draw a light wave with low wavelength and a high frequency. Well, that means that the wavelength is going to be the distance between two waves, so that means it needs to be small, and the vibrations need to be a lot. So with a high frequency, I tried to do my best with this drawing here, but I tried to show a lot of vibrations and that the distance between each wave is small, which means it has a low wavelength. High frequency, lots of vibrations, low wavelength, very short distance between the two. Now, looking at 19 here, why does the spoon appear to be bent? Well, if we look here, this is an example of refraction. And so what's happening is there are light waves that are bouncing off the spoon, but those light waves have to travel through water. And as they travel through water, they're going to slow down. And as they slow down, they're going to change direction. So the light that is getting to our eyes is actually bent, has changed direction. Therefore, the spoon appears as though it has changed or broken. Even though we know it's not, it's that the light that is coming from the spoon has actually changed direction. And the light that's going bouncing off the spoon and going through the air is going through the air much faster than the light that is bouncing off the spoon and going through the water. So this is your classic example of refraction. Now with number 20, we can see here that there is some sort of mirror in a light. So what do we know to be true? So right off the bat, we know this is reflection. If something bounces off of something, that's reflection. So we also know that these two angles are going to be equal. So the angle of incidence, aka the angle the light comes in at, is always going to be equal to the angle of reflection, aka the angle the light bounces off at. Both of those angles will always be equal. So with reflection, the two angles are equal. But with refraction, remember, those two angles are going to be different. That's why the light bends or changes direction. Now, number 21, in the summertime, why do you feel a lot cooler, not as hot, when you wear a white t-shirt? Well, because black clothing absorbs all light. That means no light is getting reflected back to you. So you're taking in all of that heat. It's making the black clothing that much hotter. Whereas white clothing, all of the light coming from the sun is reflected. That it makes its way to your eyes. So when you wear white clothing, it's reflecting light, so it's not going to make you feel as hot. And then number 22 is your example of a mirage where your brother says he can see the heat. Well, he can't actually see the heat, but what you're seeing is refraction. So here you have light traveling through air that's right above the road, and it speeds up. Well, if light speeds up, it's going to then change direction. And as it travels to our eyes, we see things now differently. Because what happens is when the light travels through different substances, it's going to move faster or slower. Well, in this case here, it's going to move faster, and that's why it's going to alter whatever it is we are seeing. So just know that this is a classic example of refraction. So looking at number 23, so when a friend is wearing red, why do we see it as red? Well, that means all the other colors, orange, yellow, green, blue, indigo, and violet, are being absorbed by their shirt, and the only one that is being reflected back to us is, in this case, red. And that's the wavelength of the color red. Remember, red has the lowest, or I guess the largest wavelength, or it has the lowest amount of energy. But red is the color or the wavelength that makes its way back to us. All right, so number 24, how do convex and concave lenses work? Well, convex lenses, they make objects look bigger than they are. And concave lenses, remember that concave looks like a cave, it curves in like that. They actually make things look smaller than they are because they spread the light out. So now as light makes its way to our eyes, convex concentrates or brings in more light, so the objects themselves look bigger. All right, number 25. So when light passes through an object, that refraction will occur. Now, when the angle of light that enters the object will always be different than when it leaves it. This is for refraction, but with reflection, remember those two angles are always going to be equal. Refraction is different from reflection. Refraction, the two angles are different. When it comes in it and what it leaves at, two different angles. Reflection, those two angles are the same. All right, why is our sky blue? Well, sky is blue because with white light, it hits our atmosphere. And it's